Welcome, students. So I am absolutely thrilled to dive into today's masterclass with you all. We're going to be taking all that messy, confusing raw data and turning it into, well, crystal clear visual stories. Imagine your digital notebook right in front of you. It's completely blank right now, right? Well, by the end of this explainer, we're going to fill it with the exact tools you need to organize literally any set of numbers you ever come across. Let's get into it. All right, here's our quick roadmap for today. We've got 6 key areas: steps of statistical research, bar graphs, dot and box plots, histograms, the stem and leaf plot, and finally, how to spot misleading graphs. Before we even look at a single graph, let's just start with a basic statistical question. Imagine writing this right across the top of your paper. What are the nationalities of visitors to the Grand Egyptian Museum today? Now, just pause for a second. Think about why answering that specific question actually requires us to collect and organize data. Well, it's because there isn't just one single answer, right? We have to observe, we have to record, and then we have to make sense of all those different responses. Okay, Section 1, Steps of Statistical Research, from question to prediction. Let's look at the blueprint. Now, many students make a mistake right here. They rush to just draw a chart immediately. But as we write these out step by step in our notes, we really have to follow these 5 logical steps. Number 1, identify the problem. 2, collect your data, using a survey or observation. 3, organize and present it. 4, analyze and interpret what you're seeing. And finally, step 5, make smart predictions and decisions based on that data. Moving right along to section 2, bar graphs and categorical data, showing actual values. So when we're handling simple categories, think favorite hobbies or foods, we use a bar graph. But hey, be careful here, and definitely highlight this rule in your notes. Bar graphs always have equal gaps between the bars. Plus, you can reorder those bars however you want. And the most important part, they show us the actual exact data values right there on the screen. Let's look at this really cool realistic data from a teacher who asked a class about their favorite hobbies. We can clearly see those raw numbers organized beautifully into this handwritten frequency table. Check out the top row. 4 students like drawing. Then we've got 3 who like acting, all the way down to 5 for music. Okay, this is a very common exam question. I want you to pause the explainer right here and try to calculate this yourself before I show you the answer. How many more students prefer music than drawing? Just look at the table we just made and figure out the difference. Ready? Let's see a quick trick and write this out together. We just take the frequency for music, which we know is 5, and we subtract the drawing frequency, which is 4, and that leaves us with exactly 1 student. Easy, right? Section 3, dot plots and box plots, visualizing the spread. Let's look at some tools for numerical data. Take a look at this box plot. Notice the smooth lines and how it's drawn directly over a number line. It's just a fantastic, highly visual way to see the minimum value, the maximum value, and that central box, which shows us exactly where the middle chunk of our data lives. Now, the crucial point is how we actually build it. Watch how we write these steps down. Step 1, we carefully arrange all our numbers from smallest to largest. Step 2, we find our overall median, the exact middle number. Then, step 3, we look at just the lower half of the numbers and find its middle, which we call quartile 1. Finally, step 4, we find the middle of the upper half, which is quartile 3. You just draw a box between those quartiles, and boom, you've got a box plot. Section 4, histograms for grouped data, handling large ranges. So what happens when we have a massive range of data? Think about math test scores in your class, ranging all the way from 4 points to 59 points. Doing a dot plot for 55 different numbers would take forever. For that, we use a histogram. Please draw a big circle around this in your mental notebook. Unlike bar graphs, histograms have absolutely no gaps between the bars, 0. The data is grouped into equal intervals, which means the actual exact individual data values are sort of hidden inside those bars. Here's a perfect example. Notice how the math scores right along the bottom are grouped really nicely into chunks of 10. We have a bar for 0 to 10, 10 to 20, and so on. This takes a massive set of numbers and makes it incredibly easy to digest at just a single glance. Time for another quick knowledge check. I want you to look at the bars for the 40 to 50 interval and the 50 to 60 interval. Can you tell me the total number of top performers? You got it. It's 18. Let's write the math out. We just take the 11 students from the 40 to 50 interval, we add them to the 7 students from the 50 to 60 interval, and we get 18 top performers. Beautiful! Section 5. The stem and leaf plot. Organizing by place value. This is honestly one of my absolute favorites. Imagine we're tracking the ages of parents at a school meeting. We can literally slice those 2-digit numbers right down the middle. We put the tens digit on the left under stems and the units digit on the right under leaves. So if you look at the first row, a stem of 2 and leaves of 5, 7, and 9 simply means we have parents who are 25, 27, and 29 years old. It organizes the data perfectly without losing a single actual number. But be careful here. Many students make a mistake by forgetting this next step. You must always write a key at the bottom of your plot. If you don't write that 3 line 7 equals 37 years, people reading your chart won't have a clue how to glue the stem and the leaf back together. Section 6, Spotting Misleading Graphs. Visual literacy. Let's finish up with something super important. This is the secret to passing your exams and honestly just being a smart consumer of information in the real world. Think about the vertical axis on a chart. A good graph always begins exactly at 0 with a perfectly even, consistent scale. But a misleading graph? It skips 0 entirely or uses this warped, uneven scale. If a graph showing student marks starts its vertical axis at 20 instead of 0, it artificially stretches those bars. Suddenly, a score of 40 looks literally twice as big as 30 on the page, which mathematically is a complete lie. That's why you always have to check the vertical axis before trusting a chart's story. On the left, a graph starting at 0 gives this calm, totally accurate picture. But over on the right, chopping off the bottom makes the exact same data look huge and dramatic, artificially stretching the differences between the data points. It's sneaky, right? So now it is your turn to be the statistician. Based on everything we've written down and solved today, I want you to tackle the laptop sales challenge in your homework. Will you use a bar graph, a histogram, or a box plot? And, more importantly, why? Think critically about what story that data actually needs to tell. Keep practicing, keep analyzing, and I will see you